financial fraud, it's everywhere, isn't it? We're a really huge problem in our digital world today. And it's constantly changing shape. With trillions of transactions flying around, 2047 fraudsters are getting seriously sophisticated. We're talking billions lost. And the sheer volume of normal transactions, that makes it really easy to hide the bad ones. So the big question, the really urgent one for everyone is, how do you possibly keep up? How do you spot the needle in that enormous haystack? Today, we're going deep. We're looking at how organizations are fighting back using something called real-time fraud detection agents, and specifically how these agents are being built right inside powerful data platforms like Snowflake to try and stop financial crime before it even fully happens.
hmm And our mission today really is to sort of pull back the curtain on the technical side, the architecture for building one of these agents. We want to show you how it spots those suspicious transactions basically in real time and then triggers alerts right away. The idea is to, cut through the jargon and focus on what really matters, how you turn data into actual real-world protection against these evolving threats.
Okay, so let's unpack this then. How does this defense system actually work? We'll cover the main goals, look at the architecture behind it, the specific bits and pieces involved, and we'll even walk through some real examples of how you build it using the source material we have. What's great is that this source isn't just theory. It gives us actual implementation details, code snippets even. Makes it very concrete. Right, let's start with the fundamental problem. Why do we even need these advanced systems? Well, the simple fact is, human analysts, even the best ones, they just can't handle the scale and speed. It's impossible. There's a great quote from Daryl Lim at the Center for Socially Responsible AI. He said, AI enables real-time detection by identifying patterns and anomalies impossible for human analysts to spot at scale.
That quote really nails it. That's the core objective of these fraud detection agents. It does exactly what humans can't spot: suspicious stuff happening now and immediately fires off alerts. Email, Slack, maybe an API call to another system. The whole point is to mitigate that financial risk before it turns into a big loss. It's proactive.
And it's not just for one specific thing, right? The applications seem really broad. We're talking about detecting fraud across all sorts of places:
Right.
payment systems, e-commerce sites, even internal company finance tools.
Exactly. Wherever money is moving digitally, basically. And when you look at the scope, the key things are, obviously, the real-time detection, but also this critical hybrid approach. It's not just rules, it's not just machine learning, it's both working together. Plus, clear workflows for handling alerts, and very importantly, audit trails. Everything logged.
Yeah, that hybrid approach sounds key. Rules for the obvious, maybe ML for the subtle patterns.
Precisely. Quick hits with rules, deeper insights with ML.
And you mentioned a performance metric that really jumped out at me. Sub-minute processing from ingestion to alert. Wow, that
Yeah.
kind of speed. It's not just nice to have, it's absolutely vital, isn't it?
Oh, completely. In fraud, speed is everything. If you're not acting almost instantly, the damage is probably already done. It really is a race.
A high-stakes race.
Absolutely.
Yeah.
And to keep getting better at winning that race, there's another crucial piece: the feedback loop. This is where the human analysts are still indispensable, even with powerful AI. They review the alerts, mark things as, yeah, that was fraud, or nope, false alarm. And that feedback goes straight back into retraining the models. It's how the system learns and adapts.
That makes sense. It's a continuous learning cycle.
hmm
Okay, so we understand the why and the what. How about the how? Let's get into the architecture. What makes this system tick? How does the data actually flow through it?
Okay, so functionally, the core needs are pretty clear. First, you've got to ingest the transaction data, streaming, batch, whatever it is, get it in reliably. Second, you need that hybrid detection engine. Rule-based triggers like, transaction over $10, or maybe lots of small ones fast. And alongside that, the ML-based scoring, looking for outliers, weird user behavior, that kind of thing. Third, trigger those real-time alerts using native integrations. Make it seamless. Fourth, log everything. Every action, who did what, when, super important for audits and compliance. And finally, you need some way for analysts to actually look at this stuff. A UI, maybe a Snowflake native app for triage.
Right, that lays out the function. So let's trace the transaction. It comes in. Where first?
Okay, input layer. Sources could be anything: Kafka streams, maybe data dumps from Fivetran, or files landing in cloud stores like GCS or S3.
Got it. Standard data sources. How does it get into Snowflake efficiently?
That's where tools like Snowpipe come in, designed for continuous ingestion. And streams on the raw table let you track just the new stuff. Very efficient.
Okay, data's in the raw table, streams tracking changes. What happens next? The detection.
Exactly. The process layer, the detection engine. The new transactions hit the SQL rules first, quick checks. Then they might get passed to ML scoring UDFs, user-defined functions. These are often Python code running inside Snowflake via Snowpark.
Ah, so the ML logic runs right there on the data.
Yep, no moving data out. The results flagged transactions land in an alerts table.
Okay, alerts table gets populated. How do the actual notifications go out?
That's the output layer. Changes to the alerts table trigger external functions. Think of these as secure bridges to the outside world. They make an API call.
It's something like Slack or email.
Exactly. Slack, email, PagerDuty, a custom webhook, whatever you need. Instant notification.
And the audit trail.
Right, audit and insights. Everything gets logged, all the events, the decisions. This feeds dashboards maybe in Snowsight or Power BI, Looker for analysis and reporting.
It's pretty amazing how it all fits together on one platform.
It is. That's a big part of the appeal. You use Snowpipe streaming for the real-time ingest, the rule engine. Just SQL views and tasks, standard stuff. Machine learning. That's Snowpark bringing Python right to the data. No complex ETL needed just for scoring.
And the alerts.
Snowflake external functions.
Yeah.
Secure, native way to trigger external actions. Plus, you get all the built-in governance features, access history, row-level security, masking, crucial for sensitive financial data.
And visualization options, too.
Yep. Native tools like Snowsight and Streamlit, which lets you build interactive native apps or connect to external BI tools. It's a very complete picture.
Okay, this is great. It really helps to visualize the flow, but let's get even more practical. The source material actually includes a lab on coding. Let's walk through some of those steps. How would you actually build this thing?
All right, let's make it tangible. So prerequisites first. You'll need a Snowflake account, obviously. Enterprise or higher is generally better for things like external functions. You need some transaction data, either a live stream or just a sample file, CSV, JSON, whatever. You need somewhere for the alerts to go, an email address, a Slack webhook URL, something like that. And a Python environment if you're going to write those Snowpark UDFs for the ML part.
Okay, got the ingredients. What's step one in the setup?
First, basic housekeeping. Create a dedicated schema in Snowflake to keep things organized. Then, create your raw table. Let's call it transactions raw. This is where the incoming data lands first. Simple storage table.
And then the stream on top of that.
Exactly. Create a stream, maybe transaction stream on that transactions raw table. This stream is key. It automatically captures only the new rows inserted into the raw table. That's what your detection logic will process, keeping it efficient.
Makes sense. Process only what's new. Now, the detection logic, starting with the rules.
Yep, the rule-based part. First, create another table, maybe suspicious transactions, to hold the results, the transactions flagged by your rules or ML. Then, you set up a task. Think of a task as a scheduled SQL job. Let's call it detect fraud rules. You schedule this task to run frequently, say, every minute. Inside the task's SQL, you write your rules. Simple stuff like insert into suspicious transactions, select from transaction stream where amount 10,000 or location equal risky place. It reads only from the stream of new transactions.
Okay, simple rules done. How do we add the ML smarts using Snowpark?
Right, so you'd use Snowpark to write a Python function, a UDF. Let's call it lscore at f. This Python function takes transaction details as input and returns a risk score, maybe between 0 and 1.
And the logic inside, what would that look like?
It could be anything, really. Simple example, start score Dexter. If amount 5,000, add 0 points. If location is in a known risky list, add 0.3. If payment method is crypto, add another 0.3. You get the idea. It calculates a cumulative risk.
Okay, so you register that Python function as a UDF in Snowflake.
Exactly. Then you modify your detection task, detect fraud rules. Now, it not only applies the simple SQL rules, but also calls your ML-score chaff on the new transactions from the stream. And it flags transactions where, say, the ML-score returns a value greater than 0.7, or maybe combines rule hits and ML scores.
Clever. So you get both rule-based and ML-based flags landing in that suspicious transactions table.
Precisely, a hybrid approach in action.
Now, the crucial bit, getting the alerts out in real time using those external functions. How does that work?
Okay, external functions. First, you need to tell Snowflake how to securely talk to your external endpoint, like Slack or PagerDuty. You do this by setting up an API integration object in Snowflake. This usually points to a secure cloud gateway, like AWS API Gateway or Azure API Management, which then forwards the call.
So Snowflake doesn't call Slack directly, it calls the gateway.
Typically, yes, for security and flexibility. Then you create the external function itself, let's call it sendAlert. This function is defined in SQL, but points to that API integration and tells Snowflake what data to send, like the suspicious transaction details.
And how does it get triggered automatically?
Another task. maybe trigger alerts. This task also runs very frequently, say every minute. It looks for new rows added to the suspicious transactions table. Again, using a stream on that table is efficient. And for each new suspicious transaction, it calls your send alert external function, passing the necessary details. Boom, real-time alert sent.
Wow, okay, that connects all the dots from detection to notification. What about seeing the results, the audit trail?
Right, the final piece. You'd typically create a view, maybe called audit log. This view joins your original transactions raw data with the flags and scores from the suspicious transactions table. So analysts get a single unified view. Here's the transaction, here's why it was flagged, rule, ML score, etc. Here's the score it got.
And that view powers the dashboards.
Exactly. It connects Snowsight, Streamlit, Power BI, whatever tool you use, to that audit log view. Now analysts have a clear dashboard for triage and investigation.
That's a really clear walkthrough, thanks.
Yeah.
It makes the whole process seem much more achievable.
But these systems handle sensitive data. What about governance and security? That must be paramount.
Oh, absolutely critical. You can't build something like this without thinking security first. Things like role-based access control, or GALEC, are fundamental. Who can see the data? Who can modify the detection logic? Who can trigger alerts? That needs strict control. Then there's data protection itself. Using masking policies in Snowflake to automatically hide or partially obscure sensitive fields, like credit card numbers or PII, from users who don't need to see the full details.
Right, least privilege access.
Exactly. And features like time travel, being able to query data as it existed in the past, and fail-safe for disaster recovery are huge for auditability and resilience. Plus, maintaining that alert history securely, probably in its own schema with tight permissions, is vital for compliance and looking back at trends.
So the platform itself provides a lot of those guardrails.
Built-in governance is a major advantage. It helps ensure privacy, integrity, and meets regulatory needs. The source also mentioned evaluating vendors or tools. What were some key criteria they highlighted?
Yeah, good point. Beyond just does it catch fraud, they look at detection quality, obviously, performance, that sub-minute latency we talked about, security features, how well it integrates with your other systems. Also, observability, can you easily monitor its health and performance? And maintainability, how easy is it to update rules, retrain models, adapt to new fraud patterns?
That makes sense. It's a whole life cycle consideration. And looking ahead, what's next? What are some future directions mentioned?
The future scope looks pretty exciting, actually, moving beyond current methods. Things like behavioral fraud detection, using more advanced ML like vector embeddings, maybe with tools like Snowflake Cortex to understand nuanced user behavior patterns, not just single transactions.
So spotting when someone's acting unusually, even if individual transactions look okay.
Exactly. Also, entity linkage, finding hidden connections like multiple different users who all share the same payment method or device ID, that can uncover fraud rings.
Interesting. Connecting the dots across users.
Right. And imagine streaming those fraud scores in real time directly to interactive dashboards using something like a Streamlit native app. Analysts could see risk scores changing live as events happen.
Very cool. So wrapping it up, that final note in the source really seemed to capture the essence.
Yeah, it did. The goal is a low-latency, explainable, and fully governed fraud detection agent. It's about combining the speed and clarity of SQL rules with the adaptability of ML, all within an architecture that's scalable and secure. Being fast, smart, and transparent. That's the trifecta.
What a fascinating dive. We've really gone from the high-level problem of fraud down to the nitty-gritty of SQL tasks and Python UDFs inside Snowflake. It's genuinely impressive how these systems can work to protect against financial crime almost instantly.
It really is powerful stuff. And that hybrid approach, rules and ML working together on a single platform, it's a game changer. It lets organizations shift from being reactive to being truly proactive, staying agile as the fraudsters inevitably change their tactics, protecting themselves and protecting us, their customers.
So thinking about all this, what does it mean for you listening in? Obviously, financial fraud is the focus here. But think bigger for a moment. Consider the principles. Real-time data, hybrid detection, automated alerts, strong governance. Where else could this apply? Think about cybersecurity spotting network intrusions as they happen, or healthcare identifying anomalies in patient data streams that could signal a problem much earlier. Maybe even supply chains predicting disruptions by analyzing real-time logistics data. What other really tough, time-sensitive problems could be tackled with this kind of real-time insight and automated response? Something to think about.